Okay. Hi, everyone. I'm Lydia Hallie. I'm a software engineering consultant, but I actually do so many things on the side. Like, I just try to motivate people to actually, start coding, especially because I'm 21, I'm Gen Z. I just want everyone to see, oh, how amazing programming can be, that it's not just, boring people coding all day and night, even though that's, still what I do, so it's probably not the best example. But I'm here today to play a game with the entire audience. It's like a trivia. Like Andrew said, I made a trivia about, JavaScript questions, just like JavaScript syntax, a bit like the tricky parts, as people like to call it. It's not really tricky, but whatever. And this went viral, and people just like to play a quiz, I guess. So I'm here today to play a quiz with everyone. Let's see if I can get my Kahoot. You don't have to join, because it's at the end of the day. Maybe you want to save your battery for your phone to actually get back home. I don't know. But if you want to, you can do that, and you can join a link. You can go to kahoot.it, and then you have to enter this PIN. And then you should see your username appear, so if you want to play along. Also, the questions are quite laid back, so either it's good for your imposter syndrome that you actually know stuff, or it's also, I cover some of the things that Tim said in the previous talk, so it's also a quiz to see how well you paid attention during that talk. Also, there's if you win, there's no prize, so just feel proud. Yeah. I'll just wait till everyone.
It's #save the internet for Wi-Fi password.
Who's Ghost? Right. Still people joining? That's awesome.
I've only got 20% battery. I'm not brave enough.
All right. Are people still joining, or is everyone in? No? Okay. I'll wait. Also, there is a 20-second, the questions last for 20 seconds. So if you're a slow reader, let me know, because I also have the questions on the slides, because 20 seconds is pretty fast, at least I found it pretty fast, but can change it, sorry about that. Okay, is everyone in? Then I'm gonna start. Oh, there's some people. How many people are there? Doesn't seem like 34. Oh, okay, but then this could go on forever, so I'll just start. Okay, I'll just start it. Are you ready? Oh, there's no sound. Okay. There was supposed to be a sound, but whatever. Question number 1. Which of the following tags can be used to delay JavaScript execution until all HTML has been parsed? Is it async, defer, prefetch, or preload? I don't know how I can get sound, if it's possible at all, but probably not. No, it's fun. Come on. Everyone should be a bit more awake, Okay, sir. Yes, almost everyone got it right. It is indeed defer. I'm just going to go back to my slides. So I'm just going to explain everything from the basics in case you just aren't used to it. So a very naive approach is to just have the script tag in the head. What this means is that, okay, it's parsing everything, it's loading and executing it all on the main thread, which of course you don't want, because we're parsing it, and during that entire time, the user can just see a blank page, right? Maybe this loading takes 30 seconds, and obviously you want to avoid this. Now you might say, okay, but everyone knows that you should then put the script tag right above the end of the body tag, right? Well, then you still have that stupid loading time, and it depends on what you have in the script, but you might want to use it. So then there's async, which is pretty cool, because then we can load it at the same time as we're parsing the HTML. So this already reduces the entire loading time. Then it still blocks the parsing, because it executes it right after loading it, which might be good in case you're using third-party libraries that you still want to use before the entire DOM has been loaded. For example, Google Analytics, you probably use async. Then you have defer. Then it's I don't care if it's loaded, because I'm only going to execute it after the entire DOM has been created, which is really nice if you're using libraries that need to have access to the entire DOM. Yeah. So one downside, or it's not really a downside, but if you have 2 async tags and the first one takes 40 seconds and the second one takes 4 seconds, it doesn't matter which order you put it because they will be executed whenever they're loaded. So, if order matters, just make sure that you actually are aware of this because this might lead to some annoying bugs. Yeah, and that would differ. It doesn't matter because then they are still, executed in the right order because they are executed after all HTML has been parsed. But most of you knew this, so congratulations. Yeah, of course it's not prefetch because with prefetch this is just saying like, okay, I'm pretty sure that you will want to use this in the future. For example, you have an e-commerce website and the user adds something to the cart. There is a very high chance that the user afterwards will probably go to the checkout, page, whatever. And if you need an image for that, you can already load it. So it's already in cache, and that goes a bit faster. So that's a very nice user experience, usually. But just be aware that you don't prefetch everything, because of course that's bad for your storage, your data. Yeah. Oh yeah, and of course preload. You're probably aware of this, but yeah. So with this is saying like, okay, I need this right now, and yeah, basically before, it would take more. Just make sure that you use it within 3 milliseconds. It's actually really important. Otherwise, you get a really ugly error in Google Chrome saying like, hey, you haven't used this within 3 milliseconds. Because normally, whenever browsers see like, okay, you want to get this data, or you are with prefetch, for example, and it sees that you're not on a very good connection, it won't always make the request. But with preload, it will still always make that request, even if you're on a very bad connection. So this might actually lead to a worse performance instead of a better performance. So just be aware of that as well. Oh yeah, and then of course with Twitter Lite, this actually is nice because it improved their time to interactive by 36% and their first contentful paint by 30%. So that's a lot. I think that was that. Yeah. Okay. Next question. Let's go back to Kahoot. There should just be a Kahoot integration in Keynote. Next. Oh, well done, Simon. Way to go. Okay. Oh, this also depends on time, by the way, so you have to be fast. So sorry if you're a slow reader. Next question. Which of these attributes can be used on an image tag in Chrome to add lazy loading? Natively, built in. Is it loading is lazy, lazy, or lazy is true? I shouldn't go too fast with these questions, otherwise I'm done within 5 minutes. But ooh, not everyone knew this, but this is quite new, so don't worry if you didn't know this. They actually got this in stable in the latest version of Chrome, but it's really awesome. Of course, everyone probably knows here about lazy loading in general. Yeah, so you can use loading is lazy. Of course, okay, quick lazy loading. Normally you would get all the images, even if they're not in a viewport, which of course is bad because you're making requests for images that you don't even see. Not optimal. So with lazy loading, we can just say, okay, we don't need it. We won't even load it until the user scrolls down, then we can see the image and so on. So yeah, this is, a CodePen just explaining or showing the new tag. I love it. I just love stuff like this. Okay, so you can go to inspect and you can actually see what's happening here. I just go to, yeah, only images, that's fine. Okay, so we have a list of just dog images, and you can see that, oh wait, should probably go, oh yeah, so whenever we're scrolling, whenever it's in the viewport, you can see that the images load. And you can be like, okay, but this is just what lazy loading always does. Yeah, I know, but now you only have to add this attribute, so loading is lazy. You don't have to use libraries for that anymore. You don't have to use whatever code you normally use for lazy load, which was always kind of annoying to add. You can just add this loading as lazy tag. Oh, wait, I'm scrolling the wrong thing. I was like, why is something loading? Okay, yeah. So this already just improves so much. Now, one downside that I noticed to this is that you can't really calculate the offset yet. You can sometimes see this flickering if the images aren't optimized either. I'm kind of waiting for Chrome to add that as well, that you can say okay, I want to actually already load it if it's 200 offset, whatever, or pixel, whatever. They haven't added that yet, but it's still a really big improvement. I love this new tag. There are also some other things that they added, but let's go back to this thingy. Where's my keynote? Oh, there you go. Yeah. So yeah, with lazy, we can do it like that. They also have auto, which just falls back to the default browser lazy loading behavior, which is of course different for every browser. And then there's eager, that's I think that's just the same as like not having any tag, but of course, like if you know, like if you're not sure whether you want eager or lazy, then yeah. All right, so this one, okay, just imagine that this box is in a browser. I couldn't really do it any other way. Okay, but what part of the pixel to screen pipeline does this animation trigger? So it has a transform, and it also fades out. All right, I just had to like show that first on my slide because I couldn't add it in Kahoot. I was like, that's fine. Okay, next. Yeah, okay, same question though. Still Simon, okay. Okay, what part is the pixel to screen pipeline? I never know what to do within like these seconds that everyone's answering. It's just like awkward standing here.
That's why you put the music.
Yeah, I know, there's no music now.
Sing.
Yeah, sing music.
Ooh. Okay, most people got it wrong. I think your most back-end people are not. Okay. Okay, so let me explain. Pixel to screen pipeline. First, let's just go back. Right. Just really quick, just like kind of, like refreshing your knowledge on this. How does a browser actually get these pixels on the screen? So the very first thing, of course, is parsing, building the DOM, seeing the HTML, see like, oh, it has a body tag, a head tag, whatever. It's building all these nodes, right, into the DOM tree. Now then we add some nice styles. Of course, it also needs the CSS, CSSOM, CSSOM. I never know how to pronounce this, but yeah, it also builds a tree with all the CSS, so it can actually apply these styles like, okay, this div needs to be green, whatever. This then turns into a render tree, and the render tree is what you're actually seeing on the screen. So if the display is none, it won't be in the render tree, right? Because we're not actually like seeing it on the screen. Next is layout. So like where should everything go? And this is important when we've added like width, a height, an offset, whatever. The browser needs to calculate all of this. I make everything like mobile first because everyone's like using mobile anyway. Then painting. Yeah, so that's actually where the pixels appear on the screen. So it like the browser builds layers and like it shows, okay, what actually needs to be there. It doesn't have to be green, yellow, this is a box, whatever. And then there's the composite part. I would probably say compositioning. I don't know why I always say compositioning. When I say that, just know that I mean compositing. But this is a very important part because this is actually where the browser builds the layers. Because of course, like if we have two boxes, one of them needs to be on top of the other. Like the browser needs to know which one has to be on top. So how does it actually do that? Now there are actually two threads. So we have the main thread, UI thread, which you probably know. So this is the styles and layout and painting all happen on this thread as well as your normal JavaScript execution. Now imagine that we're constantly like repainting or recalculating our styles while our JavaScript is also on this main thread. That means that we get a kind of a laggy animation, which I'll show later. But compositing happens on the compositor thread, and this also has access to your GPU. Now, of course, you know that like GPU is built for animations, right? It's built for graphics, which is really, I just saw that the iPhone 11 got released and they didn't like change their GPU and CPU, which is kind of, this was totally off, not in the point, but saying that the GPU is a very important part of, like adding smooth animations instead of just your CPU. You can see that difference here. Now you might not really see it, but one of them is using the GPU, one of them is not using the GPU, it's just using the CPU, and that's the one on top. Yeah, you can't really see it from the side, but it's kind of flickery. It doesn't look good, right? And especially when we see it in Inspector Tools, and we go to, let's see, rendering paint flashing, you can see a green border. And this is always where painting happens. Now the painting happens, of course, on the main thread, meaning that everything is blocked because it's painting the entire time. The browser is constantly recalculating, like, okay, you're doing something bad. And you can also see this in the performance monitor. You can see the styles calculations per second. You can see that right here. It's actually recalculating it like every animation frame, which you obviously also don't want. Yeah, so why is the one beneath not using it? It's because we're using the compositor thread. Let's just go back. No, I don't want to open VS Code. Muscle memory. Okay. All right, yeah, so what happens normally is like we're having a keyframe, so left 0 pixels to 70 pixels. So on every single animation frame, we recalculate it, we repaint it, and send it to the GPU to like manage that stuff. Now this is quite bad for your performance, because every time we do this, we're blocking the main thread. Instead, we can use transform, which actually just gives us access to the GPU, and then we can have like a separate layer to animate it instead. You can kind of see this as if you're like having two papers and they're just like going over each other. And this is really cool because we're already telling the GPU like, hey, I know that first you're at 0 pixels, then you're at 70 pixels, and it only needs to know that difference instead of having to recalculate the entire, everything you see on the screen at every animation frame, which is bad. But then there's a downside, because now you might say like, okay, cool, I know that I have to animate this using the GPU because that adds it smooth, but you might end up with something called implicit compositing. So due to the stacking order, a composite layer is promoted to a non-composited element, which sounds super vague. But yeah, let's just imagine that you have one thing that uses, that's like animating on the GPU, and then there is something on top that's not animating. So what does the browser do? It adds an extra layer, which is not always good. And you can see that here, what's happening. Of course, the code sandbox doesn't work. Just gonna reload. So you can actually even see that happening here in the layers thing, which is really cool. I love it. Okay, so you can see here that the browser is actually creating these layers. And you can also see the reason why it's adding these layers. I just got to scroll up. This is really difficult on a laptop when everything is so tiny. All right. So one of them, which is div with the ID of D, is compositing reasons because there's an active transform animation, which I just showed because there was this transform with like 70 pixels. But then div C is composited due to the association with an element that may overlap other composited elements. And you can also see the memory estimate, which is actually what this is all about. So there's 244 KB memory like sent to the GPU, which actually you didn't want. And especially on mobile users, we're sending memory to the GPU only for like this ugly red div pixel thing, which is just extra memory that's bad. You want to avoid that. Why do I keep on opening VS Code? Wait, why is it not? I'm clicking it. It's just not opening it. I love my MacBook. Like, you see I'm clicking it, right? Okay. Oh, wait, it's just, oh, it froze.
So the full screen does that, right? 3 fingers for
I'm trying. I'm trying. Okay, there you go. Okay. No, like it actually froze because like I'm touching things in it. Oh, okay. Okay, well this is actually a more efficient one. So this is implicit compositing that happens quite often when you're working with front-end things. So we have a cool animation and we have some overlap. Now let's just look at all these layers. All of these things go promoted to their own layer, and whenever we see these layers, it's just like really bad, right? Now, of course, like they're kind of tiny. They're 4.4 KB, but still, this is bad because it's still composition due to association, blah, 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 blah. Now, how do you solve this? Well, it's actually really easy. We can just say like, okay, position, relative, and the z-index is 1. So now we're saying to the browser like, hey, the animation thing actually has to be on top of all these other things instead of underneath. So when we now look at layers, you only get 3, which is already like a huge improvement if you don't want to like bomb your mobile user's GPU with some stuff that you're making. So this is actually something that I never really thought of before, but then I crashed my browser constantly when I was building something. I was like, what's going on? And I just had like a trillion layers. So just be aware that you're actually, okay, this went well. Using these animations on the right one. Now what can actually cause these animations, or layers, composite layers, sorry, like translate video, canvas, iframe, opacity, which is like kind of not obvious, position fixed, will change and filter. So don't use an iframe like underneath all of these elements because you will probably add so many layers that you might not even know. Oh yeah, next question, you'll probably know this, but what runs separate to a browser's main thread? What? I just gotta go back to Kahoot. Okay, next. Ooh, Tim is on top now. Cool. Next question. So what runs on the separate thread to the browser's main thread? Is it service worker, dedicated worker, service worker, a dedicated and shared worker, service worker, shared worker, and a worklet, or service worker, shared worker, and a worklet? You could probably read. I probably didn't have to say all of these, but whatever. Okay, I like this. Yeah. Okay, well, we already have the winner. It's Tim. Congratulations, Tim. Who's Tim? Oh, congratulations. Oh, you're. Oh, of course. Nice. Well done, Tim. All right. Yeah, so in case you weren't familiar with the workers, yeah, just a quick walkthrough. So what's a worker? It's a script that runs on a thread separate to the browser's main thread. So this is perfect if you have like heavy calculations. You of course don't want to have that on the main thread, right? Because like, well, that takes a while. Very good example of this is like this, yeah. This thing, so it generates pi, and you have this like spinner thingy, right? And then you generate it. Ooh, wow, that's a lot of work. So the main thread's blocked, so the animation doesn't work. Now I actually have to wait because okay, well there you have pi. I'm just gonna refresh it. So if you now do it on a worker, everything's still working, right? It's still spinning, and it's calculating it in the background, which is awesome. It's doing it on a different thread, and now we got it. So like during that entire time, it was calculating it. We still had a responsive website, which is our goal, right? So let's just get back. Oh, okay, this just doesn't work. Okay, there. Now, of course, there's a dedicated worker and a shared worker. Dedicated worker, we can post messages to just one script. And a shared worker, it's actually kind of cool because you can still have the same worker, but in different tabs. So like different tabs can still communicate to each other. I didn't have time to like build this stuff myself, but this is a really nice example. Okay, so like 10 times 2, whatever. So this is 20, and then go to second worker page. So square this number for, I don't know, 16. Wait, that doesn't, oh, wait, oh yeah, okay. 2 times 2 is, yeah, okay, I'm really bad at math. So yeah, so they shared, so the first tab and the second tab. Wait, that doesn't make sense, does it? 20, the square number of, yeah, but they should, okay. Oh, okay. This was a different example at first. I'm so confused now because first it like used the previous result and then it used that result on a different, whatever, you get the point. They can communicate, different tabs can communicate because they're like communicated to the same thread, which is a worker, which is kind of cool. Yeah. Right. Oh my god, okay. I'm almost done, don't worry. I only have 2 slides left and I don't have to go to the browser again. You can have your pizza soon. Right, and of course service worker, a proxy between a browser and a network for cache. Yeah, you can use cache only that doesn't use a network, which is great if you like want to avoid screens like this, like they're loading, or you get the annoying dinosaur game, and then you play the dinosaur game and then you get internet back, so like you can never reach your high score. It's really annoying. So like you can use a service worker for that as well to only read your cache, and you can create an app shell with that. So whenever you know your user has already visited your website once, and you know like, okay, I'm kind of going to show these contents later on, I can just use an app shell. So you know, it looks as if I'm actually loading something, even though like it might be entirely crashing, but your user will never know that because it sees like nice divs anyway. Yeah, network only. I won't really explain all these service workers because I feel like they're pretty obvious. So first with cache, of course, like, yeah, if you want to use cache first and it doesn't work, then it goes to your network. Or first network and then cache. So this is actually important if you like want to have resources that actually update all the time, like a user's email inbox. You don't want to like, you know, show old emails. You actually want to see the updated ones. Whereas with the cache first, it might be like user avatars. Like I don't really care that Sarah updated her avatar if it like makes my experience worse. Just get her avatar from the cache first. Even if it updated after, that's fine. Like we can cache it later on, but just show her old avatar first. Yeah, that was what we can do with cache. Oh, and worklets is actually really cool. So I didn't even know about them until like a month ago, but worklets are new to Google, and they give you access to the rendering pipeline. So we can like create something like a checkerboard painter, and you can like create all this with whatever. So you get like a checkerboard pattern kind of, and then either in JavaScript or in CSS, we can then add this worklet to like a background image. So we actually get access to the rendering pipeline. So like the painting and the compositing part, which wasn't there before. So I'm really excited about that because it gives you far more like control over that entire rendering pipeline, as far as I know. This was everything. Well, congratulations, Tim. You're really good at the web performance.